So, hi, in Tech X5, there are some additional tips that I wanted to share. So, there are a few things that you will come across in X5, right? You already know about interest, right? So, let's talk about the interest. What are the different type of questions you could come across? So the first one would be like, hey, there's a person, let's say Albert, wants to invest $50, right, in a savings account. Okay, so the interest rate is, let's say, 5%, and he invests this money for 5 years. Okay, so if you get this scenario, how do you solve it? So we already know that there's a formula, right? So this is the amount. This is the initial amount or the principal. This is the rate percent that they give you, and this is the time in years. Time, let's just write it as time instead of putting a parameter in years or something because it can be months, it can be days. So this is our main formula that we are using, right? Concentrate on that. Remember the different attributes, the different elements that are part of this so that you can easily solve it, okay? So let's plug in the values. So we want A. We know P is 50, the amount he's investing. We know this is 5%, so remember R percent is equal to R divided by 100. And we know the exponent is 5. So if we plug all of this in our calculator, we'll get 1 plus 0.05 exponent 5. 50 times 1.05 exponent 5, right? You use this caret thingy on your calculator. So on your TI-84, you'll see a division, and above it you'll see a caret. So that's for your exponent. Okay? So that's what you'll use for the exponent part. So after we solve this value on the calculator, we get 63.81407,813. Obviously you won't get this in cents, but let's just consider these digits to round it off to the nearest cent. So we would end up getting $63.81. Okay. So this would be the amount, total amount after 5 years. Okay, so if they asked, hey, what's the total amount after 5 years? This is what you would state. But if they ask, hey, what's the interest that you gained or the profit, you'll take your initial amount and you'll subtract it from this value. So we got A right here, and we know P is 50. So we'll do 63.81 minus 50. So our interest will be $13.81. So if they ask for the interest, this is the amount. So there will be some questions which will ask you about this. Okay. There will even be questions about population growth, like the population of a certain town is increasing in a certain way and stuff like that. So that's how you'll solve these questions. Okay, so we spoke about interest in the previous slide. So whenever there is an increase, we'll use the interest formula, okay? When there is a decrease or a decline, that's when you'll use the second formula, which we normally use for depreciation. So here we're subtracting the percentage, right? So this is our second formula that you want to use. So let's say if we were in a town, right? Town A has a population, and I'm creating these questions as I'm writing it, of 25,000, right? The rate of decline of the population or decrease of the population is 2%, right? 2%. So let's say we want to find it in 7 years. What is the population after 7 years? So again, we'll use this formula. A is equal to P 1 minus R percent T. We know R percent is R divided by 100, right? This is our new value or new amount, whatever you want to define it as. But this is the end value. This is our initial value, initial amount. This is our rate percent, and this is our time in years. So again, let's block this. That's what you're looking for. This is another important thing you want to remember, right? So that's all. So what do we get? So now if we were to put in all these values again, $25,000, 1 minus 2 divided by 100, because 2% and 7 is the exponent. So we got 25,000. And let's plug in all this. So 1 minus 2 divided by 100 is 0.98, exponent 7. $21,703.13833. Now obviously a population can't have 0.13833. So let's round it off. So 21703 people. Now again, if they want the decrease or change in population, right? If we were to do the decrease, what do you think we should do? Decrease in population would be P minus A, right? Because P is larger. So 25,000 minus 21703. And the reason why we took the whole number is it's because of people. But if it were dollar amounts, we would take the 100th of the digit to determine the dollar amount. So you've got to use logic when you're solving questions. So this is when we have a decrease. So another concept that is part of X5 is the half-life. Now half-life is actually used in nuclear explosions and stuff like that, nuclear reactions, and also in medication. For example, if you were taking a medication and you just wanted to go to the doctor and say, hey, I don't want to use this medication anymore, uh, probably that wouldn't work directly. You can't just stop taking medication. Now, let's see how it works, okay? You'll get a better idea. So, let's say if you're taking 40 mg of a certain medication, and the half life of the medication is 3 days. So what I mean by that is after 3 days, after every 3 days, the amount of medication is half the previous amount. So if we were to plot this, right? So check it out. If I were to plot this graph, so let's put amount of substance and days. So zeros, because it's 3 days factors, so let's put 3, 6, 9, 12, 15. Right, let's work till here. And then we've got 40 mg, so let's go so 10, 20, 30, 40, and so on, right? So we've got this. Now we've got this graph for half-life. So whenever you're given a question for half-life, just use this idea of dividing your amount by 2 every time. So you're going to half of the amount, right? And keep doubling the amount of days that they've given you. So for example, let's say if there were a question, hey, it's starting at 100, right, on day 0, right? And the half-life is 2 days. So keep increasing the days by 2, so you'll go 0, 2, 4, 6, 8, 10. And keep going down by half for the amount. So from 100 you'll go to 50, then you'll go to 25, then you'll go to 12.5, then you'll go to 6.25, and then you'll go to 3.125, right? So your calculator can get you these values. Just keep dividing by 2 for the amount. This is divide by 2. And this is add number of days. Add number of days. So that's how these columns are working. There will be a couple of questions. Check it out and you'll get it through. So another concept that is related to half-life is growth. So for example, the population of a town doubles every 17 years, right? The population or the current population of the town is 5,000. What is the population after 68 years? So let's plot this graph. So the population is doubling every 17 years. So at 0, it's at 5,000. After 17 years, it should become 10,000. After 34 years, it's 20,000. And then after 51 years, it's double of that, which will become 40,000. And then finally at 68 years, it's at 80,000. So this is another question that you might come across, right? So let's plug in these. Sorry, it's at 0, it's this value, so it's over here, then here, then here. So it's more like that. Or if you were to plot it better, let's say if this is 5,000, right? Then 10, then double of that would be 20, then double of that would be around here, and then it would be maybe here at 80,000. So population in thousands. So if you were to plot the shape will show you the exponential feature more elaborately because it's a better representative of the data. So you get this shape. Okay? So this is another question that you might come across. So there was half-life versus growth. So half-life, right, where everything divides by 2. And then growth is everything multiplying by a factor. Maybe doubling, tripling, and so on.